All right, well, we'll go ahead and get started here. Hello, everybody. Good morning, good afternoon, good evening. I'm really excited to be able to bring everyone this webinar today. We've been working with the state of Indiana, with AWS, with Opto22, and numerous other partners over the last 18 months to put this very innovative program together. And I'm really excited to be able to talk to you about it today. So today, we'll be joined by Paul, who is the president and CEO of Energy System Networks, Poogle, who is the principal partner development specialist with Amazon Web Services, myself, Arlen, with Cirrus Link Solutions, and Arthi, who is the lead data scientist for Mega AI. For today's agenda, we'll be doing, I'll let everybody do introductions when it's their section. We're going to talk about the Energy Insight initiative that the state of Indiana is rolling out. And then we'll look at how Amazon has helped activate that program using the Insights MVP product. Then I'll quickly go through the machine, the cloud connectivity, the Industry 4.0 in a box. I'll describe from a technical standpoint and how it works and do a live demo of that. And then we'll take a look at, once we have that information in the cloud services, how we can use AI ML powered insights and a demonstration of that as well. Towards the end of the presentation, we will leave some time for questions and answers. If you have a question, please type it into the entry for the questions, and we'll try to get to everyone's questions at the end of the section. So, and I will note here that although this is a very special day, I'm glad we could bring this. This is also just happens to be the 10th anniversary of Cirrus Link Solutions. So Chris and myself, 10 years ago today, we're actually sitting in my basement coming up with the idea of starting Cirrus Link Solutions. So it's been a fantastic journey and really appreciate all of the customers that we've got today. So with that, Paul, I'm going to give you keyboard and mouse control, and I'll let you introduce yourself and go through the Insight program.
Thank you very much. It's a pleasure to be joining everybody virtually. Paul Mitchell, I'm President and CEO of Energy Systems Network. We are a nonprofit organization based in the state of Indiana, working in the alternative energy and advanced transportation sectors. We are a close collaborator and really an extension in many ways of the state of Indiana, specifically the Indiana Economic Development Corporation, which is like Indiana's Department of Commerce, if you will. I've been in this role for going on 13 years, and prior to that, worked in governor's office of a previous governor in the state of Indiana named Mitch Daniels. Let's see, next slide here. I'm trying to progress the slide.
I can do that for you, Paul.
Great.
Hang on.
Yeah, thank you.
There you go.
Great. So a little context on Energy Insights and how it came about, the overall vision and objectives. One thing that's important for everybody to understand, Indiana is the most manufacturing intensive state in the nation, as measured both by GDP and by jobs. And we've been in this position year after year for the last several decades. We're a rich history in manufacturing in a number of different sectors, automotive, pharma, food and agriculture, heavy metals, chemicals, you name it, we build it in the state of Indiana. And we have a long history of attracting a lot of very energy intensive manufacturing rather, and that has been driven by Indiana having been a low-cost energy state for many, many decades. Initially because of the discovery of natural gas in Indiana at the turn of the century, and then for many years, more than a century actually, our access to coal. Indiana has a lot of coal, and as a result, we were the third lowest cost energy state in the US in 2005. That's when things changed. There was a lot of increased regulation on coal, particularly the high sulfur coal that Indiana produces, and then also just changing in the markets around natural gas pricing, et cetera. That led to a rise in our energy costs. We're somewhere, I don't know if it's exactly 25th, we're somewhere, I would say, middle of the pack now compared to other states. And that's had a big impact on our manufacturing industry, particularly that energy intensive industry that I mentioned earlier. And where that impact is maybe most clearly felt is among the small to medium sized manufacturers, where energy makes up a significant part of their overall cost structure, and where they may not have access to the capital or the resources or even the technology to reduce their energy costs. The state of Indiana has been trying to figure out ways to address this problem at least for the last 4 or 5 years, and came to the conclusion that there was really no way that you could go company by company and try to overhaul their operations, change out machinery, modernize all of their equipment, or change their buildings. That there had to be some way to leverage these new advanced technology trends that we're seeing in industrial IoT, cloud computing, data analytics, to look for ways to bend the cost curve to reduce energy consumption without significant capital investment. And that's exactly what Energy Insights seeks to do. We were fortunate to find an exciting and very capable partner in AWS, who then, of course, introduced us to companies like Cirrus, Mega AI, Induction, Opto22, and others who had been working together to validate and prove out kind of a state-of-the-art solution that we'll hear about today, that combines the power of industrial IoT, data science and analytics, AI, and delivers an Industry 4.0 solution for small to medium-sized manufacturers that is very low cost, very low touch, and that can, at least initially, help them in reducing their energy costs, we think by as much as 10% or more. The kind of secondary benefit of this, if you will, is that the same solution that can help companies with reducing energy costs can also help them with other operational efficiencies. It's, as we say, sort of serves as an Industry 4.0 on-ramp and exposes these companies, small to medium-sized companies, who maybe think of Industry 4.0 as a rich company's opportunity, or big corporation, multinational corporations opportunity, and exposes them to a way in which it can be applied in a very practical setting within an organization that might just have one factory, with 50, 100,000 square feet and a couple hundred employees. So we're very excited about where this is headed. It's a deep partnership now between industry, the government of the state of Indiana. The Indiana Economic Development Corporation has been investing more than $5 million into rolling this initiative out statewide, where we hope to reach as many as 100 companies through the balance of this year and enroll them in this Energy Insights program. But really, the goals are much broader than that. We really want to reach as many of the 8,000 Indiana manufacturers as we can, and ensure that Indiana is a leader in transitioning to this Industry 4.0 future. So I will stop there and turn it over to my colleague, Arlen, who I think is going to pass it on to Pagal.
All right, thanks, Paul. And I'll just mention that when we get to the end of the deck, we do have a link to the website so that anybody can find out more information on this program and how to get started. So with that, let's see here. Pugal, I'll give you the keyboard and mouse, and we'll go to advance here. So Pugal, I'll let you take it away.
Okay, thanks, Arlen. Hello, everyone. Again, quick introduction. Name is Pugal Janakiraman. I run the worldwide industrial IoT partner solution development for Amazon Web Services. And I've been working with, as Arlen mentioned, with state of Indiana, which is Paul and the IEDC and various other folks in state of Indiana for more than 18 months in bringing this vision into a reality, which we are rolling it out around the state. Again, obviously, Paul mentioned it and explained it so well on what is going on in the state of Indiana. Living in a neighboring state in Michigan, I never realized there is so much industrial activities happening in state of Indiana and how big of a powerhouse Indiana is from a manufacturing point of view till I started this journey. And it had been a fun journey working with amazing thought leaders in state of Indiana who wants to take the state's manufacturing facilities into the next generation and making sure Industry 4.0 solutions are accessible. And even a small and medium companies can leverage artificial intelligence and machine learning technologies to do analytics, which is a dream even for a very large companies today. They are still in an early part of the journey. That's what has been an exciting journey for me in showing the art of the possible in leveraging the latest and greatest of the technology. Again, as mentioned in the slide, this is a collaboration between state of Indiana and Amazon Web Services. And with that, let me do a quick overview of what is going on in the industry first, before I talk about details around the solution. Again, to quickly recap, the biggest industry trend which is happening today and why Amazon is so focused on this area of Industry 4.0 is because data-driven insights around manufacturing is the biggest buzzword today. People are trying to understand the data which they have been generating for the last 30, 40 years are an outcome of the third industrial revolution, which is primarily the PLC and automation work which happened a couple of decades back. And data has been generated for the last few decades. Currently, the promise of a low-cost compute in the cloud and along with much better analytical tools like artificial intelligence and machine learning capabilities being made more and more accessible as a pre-built solution. The biggest wave happening today is companies trying to unlock the potential of the data to streamline and improve the manufacturing efficiency by anything from 10% going up to 30, 40% in number. That's where the industry is trying to go. This is the biggest trend happening today. And again, one quick thing about this trend is, unique thing about this is, unlike a connected car platform or building a connected product, this is a brownfield environment. Companies have taken the decisions to go with a PLC or an automation equipment a couple of decades back, and that is not going to change for the near future. Anything we provide here has to make sure that we are not going to disturb that infrastructure, and without disturbing it, slowing it down, asking them to invest more capital equipment. The goal here is to leverage the data being generated to derive deeper insight to streamline the manufacturing operation. That's pretty much the vision behind Industry 4.0 and why there is so much interest. And every manufacturer wants to adopt an Industry 4.0 solution for some data-driven insight. But having said that, it's not an easy journey for customers because overall, if you look at the industry today, most of the small and medium businesses we deal with, which is 95% of the manufacturers in the world today, independent of Indiana or anywhere else, they don't have access to any type of data, which is the machine data or energy data, unless it's a big manufacturing company who might have invested millions of dollars and built a factory information system or historians and systems like that a couple of decades back and got access to the data. These small and medium businesses, most of them I deal with today, Indiana or anywhere else, have never even seen the data. And they are trying to do insights and do maintenance activity based on experience, not based on analytics around the data being generated from the machines, which can give them a much better decision-making capability. And the problem gets worse. In fact, even if you have access to data, most of them don't have analytical tools to correlate the machine performance with respect to a shift or with respect to a manufacturing process or why there is a downturn in quality or various other plant KPIs they care about. This is a common problem we deal with daily. And nearly 100% of these manufacturers don't have access to artificial intelligence and machine learning tools to do analytics on this huge volume of data being generated. Because even if you take like 5 or 10 machines today, the amount of data it generates is huge, and deriving insights out of it by a human mind, it's not possible. You need superior big data analytical tools like artificial intelligence and machine learning to derive meaningful insights out of it. So this is what we are walking into. Added to that, if I go a bit deeper into the energy side of it, based on the work we did in Indiana and various other locations, a small manufacturing business spends anything from $250,000 to $2 million in an electricity bill per annum. Medium businesses, anything from $1 million and up. Obviously, there are large companies like final assembly plants, things like that, spends much larger amount of money. So there is huge amount of value for these customers to understand energy consumption patterns beyond the bill they get at a power meter level into a line level, machine level, where there is energy spikes happening, anomalies happening, and leverage the tools we provide to provide a meaningful correlation to reduce energy. So this is pretty much the challenge we are seeing in the industry, and there is a lot of value for companies to go use an Industry 4.0 platform to derive benefits around streamlining their energy consumption. Having said that, the vision behind Energy Insights is pretty much, as Paul mentioned, overall the goal is to reduce the energy consumption by 8 to 10% at the demand side. We are talking about manufacturing plants. We are not talking about power generation or power transmission. This is primarily on the consumption side at a manufacturing facility. Today, they get a bill every month on what their peak load is and what their energy consumption is. Beyond that, they have no visibility on why there is an upswing or there is an anomaly happening in power consumption. So we want to make sure that that level of insights are available. That's one. And the other capabilities we are providing as part of this, what we call it as MVP, minimum viable product, which we are rolling out in state of Indiana, is also a forecasting capability to forecast energy, and not only for energy, various other machine KPIs, so that the manufacturer can purchase energy in the open market in a much more efficient way. That's a longer term benefits they can derive. Obviously, as Paul mentioned, what we are providing is an Industry 4.0 platform, a full-blown Industry 4.0 platform, where not only they can derive this benefits, they can also gain overall 10 to 20% improvement in overall manufacturing efficiency by streamlining their maintenance operation, quality operation, how they perform root cause analysis when a line or a machine goes down. Every one of these capabilities are pre-built into the solution offering. So that's pretty much is the program vision. Having said that, the solution architecture we came up with, this is pretty much an industry standard or an Industry 4.0 architecture provided by ISA, International Society of Automation, where most of the small and medium businesses are in level 0, pretty much an equipment out there producing something, or maybe they are using a PLC to automate their plant equipment to streamline production. At the best, that's where they are. But pretty much all these companies wants to be at level 4 and 5, where they can get deep data-driven insights, which is powered by artificial intelligence and machine learning. That's where they want to be. But obviously, to get there, somebody has to do a heavy lifting and make sure that take a whole bunch of solutions from various partners, which I think we talked about, and integrate all the solution together, and then bring it together to move the customer at the lowest possible cost to level 4 and 5 at the lowest possible effort. That has been the challenge we have been trying to solve, because when we started this journey, the price point was different. The time it takes to implement a solution like that are weeks in timeline. If you have weeks in timeline with a 100 customer goal, you don't have enough weeks in the year to go implement this. That's what we realized 3 months, 6 months into the program. So we had to put together a whole bunch of work, and there was huge amount of investment which was done by the state by bringing together a whole bunch of partners and pre-building the solution and proving it out with a bunch of customers, obviously working closely with Amazon, who provided the solution improvement and a vision on how to make this happen. And out of this came what we call it as an Industry 4.0 in a box, where we pre-packaged a solution which is ready to deploy. In matter of 2 days, you can go drop this box into a plant floor. 100% we can configure, connect a bunch of machines, a power meter, and derive meaningful insights into the cloud, and leverage an artificial intelligence and machine learning tools. The goal for this is less than a week, a customer should be up and running, and based on the initial installation and all of it, once the firewall is opened up and once there is basic level of plug points and things like that are available, this installation configuration can be done in less than 2 days. That's pretty much where we are. All of it happened because of the thought leadership and the vision which was put together by State of Indiana. And not only they put the vision, they drove a whole bunch of partner ecosystem, continuously pushing the price down, continuously improving the installation process, continuously making sure that all the partners involved here are delivering what they are looking to deliver, and which is pretty much what they did, obviously in context of real customers. We took a bunch of real customers, proved it out, and then learned from them, and continuously we improved the solution. That's pretty much what happened. Again, as mentioned earlier, the partners involved, they are a hardware partner called as Opto22, who provides energy monitoring units and various other technology to pull the energy information out of our meters and our machines. Ignition from Inductive Automation, who provides deeper integration to pull any type of OT data which is residing within a machine or a PLC or a SCADA or a historian, wherever it is resident today. And Cirrus Link, an amazing partner who has been instrumental in driving this forward with their, I would say, limitless energy which Arlen brings to the table, with which they provide the capability to bring these various different protocols, convert that into one consistent MQTT protocol, which is makes the whole process efficient and reduce the amount of network load, the machine load, all of it happening today, and integrate that into AWS Sitewise, which provides the asset modeling in the cloud. And Mega AI came together to provide the full-blown insights capability with not only visualization of data, which is nothing but table stakes for most of the company, but the real value is providing an artificial intelligence, machine learning-based deeper insights at an asset level, and make sure that that is available without any coding. You don't need a data scientist anymore. You can select an asset in the cloud in a visual format, and then turn on artificial intelligence algorithm to track the performance of the asset, detect anomalies, and then report out anomalies. And all of it, this happens in like installation process is a matter of hours, and configuration is less than 2 days. We can get a customer up and running. That's pretty much what happened here. Okay. With that, the benefits of this, as mentioned earlier, 8 to 10% savings in energy, and overall 10% plus efficiency in the manufacturing KPIs, which customers care about, which is on how to do root cause analysis when things go down, are improving the maintenance to do predictive maintenance. The approach taken for doing that is pretty much gather all the process parameters, energy metrics in near real time, and build predictive models associated with it, and also understand the patterns, understand the deviations in performance, and let the users know that there is a spike happening here, and that spike is happening because of so-and-so reasons as per the anomaly detection algorithm provided. So an expert user can immediately perform a root cause analysis instead of trying to scramble around with voluminous amount of data. And that's pretty much the benefits we are providing as part of the journey. And the approach and the rollout schedule is, for this year, it's around 100 manufacturing sites. The approach again taken here is executive sponsorship at the topmost level, and identify the customers, which is happening as we speak. Create the Amazon virtual private cloud, because end of the day, most of the customers don't want this data to be resident in a public cloud environment. They want this to be in a private cloud where only they have access, so nobody can get access to this data. And once this Machine Insights platform is installed, it establishes connectivity into the machines and also establish connectivity into the cloud to publish the data in near real time and provide insights. And in addition to that, we do on-the-job training for onboarding the customer on not only on how to use the system, how do you connect more machines, how do you configure the software. And added to that, a unique aspect of this program is not only that, every quarter, the customers can come over to the advanced manufacturing facility in Indianapolis, EMC Square, where they will be taught how to do other things. For example, this industrial IoT platform, how do I do better quality control process? How do I construct an OEE dashboard? How do I go connect to a machine which they don't know how to do it? Every one of it will be taught as part of this program for the customers. So Again, the scope, to be clear, this is a fully funded by the state for every one of this, what we call it as minimum viable product. The scope of it includes connecting to one power meter, which provides contextual information of energy consumption, and a maximum of 4 machines to get detailed metrics from the machines, which is not only energy data, pretty much every other OT metrics you can pull out of the machine. And you can do maintenance or various other use cases as well with the energy provided. Out-of-the-box capability provides near real-time insights on energy and process parameters, and obviously deeply integrated with artificial intelligence and machine learning capability. And energy forecast is in the roadmap. It's being worked on by the partners here, and that will be available. And on-the-job training on how to onboard additional machines as part of the rollout process. Okay. With that, quickly to recap, as I mentioned, even though this is Energy Insights, what we are providing is a full-blown Industry 4.0 platform for fully subsidized by the state as part of the MVP, and that pretty much covers a complete plant-level enhancement if the customer wants to do, and with which the other capabilities which is included, which they can pretty much do today, is perform a root cause analysis. When a line goes down, micro stoppages happening in a high volume industries or failure happening, things like that. Or the customer wants to do predictive quality. We have deeply integrated artificial intelligence service from Amazon called as Lookout for Equipment, or the partner Mega AS integrated, that provides the capability to do predictive quality or a predictive maintenance by understanding asset performance or understanding the quality metrics and correlating it back to which machine parameter or parameters lead to that failure issue or leads to the downturn in quality. Also, they can construct OEE dashboard and all of it with this dashboarding framework being provided. So the full-blown Industry 4.0 platform, what is being provided. Again, the rollout approach, this is something which is extremely unique, what we have seen from even from an Amazon side. I'm working with a whole bunch of other government organizations, but here the leadership of Indiana has taken a pretty unique approach where it's not just about rolling out and giving funding to the customers. They are giving a pre-built solution and proved already the pre-built solution with a deep opinion on what the capability should be, what the partners should be doing, and also continuous process to reduce the cost. And all of it has been done by the state. And obviously with the latest and greatest technology, deeply integrated. So a small and medium business today can do data science, not just a very large companies in the world from now onwards with this approach. And the other program, as I mentioned, is called as Bring Your Machine to Work program, where at the EMC Squared, or the manufacturing factory of the future set up in Indianapolis, every quarter, the state, along with the partners involved here, including Amazon, we will be teaching the customers on what other things you can do with it. How do you enhance quality or productivity, supply chain optimization with the same platform? And also, we are collaborating very deeply with universities like Purdue, Notre Dame, and various other colleges with very different kind of incentives provided by the state to build predictive models to work on much deeper problems like optimizing energy in an HVAC system using reinforcement-based learning, for example, or optimizing compressors for a maintenance or energy optimization. Common asks in the industry at a plant floor, and the lowest common denominator. Every plant, whether they have a CNC machine or a welding machine, they always have an HVAC system and a compressor unit where there is significant amount of energy consumption happen, and there is a lot of problems associated with it. We will pre-build this model working with the state and the universities, and then make sure these models are available free of cost for the customers to use on the same platform. That's the approach which has been taken. And to summarize it, pretty much this is the proverb which comes to my mind, where we are not just giving food for an hungry person, but we are teaching them how to feed for themselves. So that way they can sustain themselves and they can leverage a technology like that and continuously do improvement with their manufacturing facility. That's the approach. It has been an amazing experience working with the state, and there should be more fun this year to see the results coming out from these manufacturers who are asking for the solution. With that, I'm going to hand it over to Arlen. Thanks, Arlen.
Thanks, Poogal. That was great. So real quick introduction to myself. My name is Arlen Nipper. I am the president and CTO of Cirrus Link Solutions. I've been doing industrial communications and automation for this year will be 43 years. kind of halfway through that career path, about 22, 23 years ago, I was very privileged to work with a IBM fellow by the name of Andy Stanford Clark, and we were working on a project for Phillips 66 pipeline in Bartlesville, Oklahoma, where they had just been provided TCP/IP satellite network, but wanted to be able to make that work more efficiently. And so I was one of the co-inventors of MQTT. Now, that technology is what we're going to leverage as part of this overall solution for the state of Indiana. So putting it all together, kind of a topology and where we've been. As Pugal said, we've been working with Amazon for over 8 years now in all kinds of Industry 4.0 solutions, if you will. And if we look back, kind of the lessons learned over the years is that the first thing we tried to do was get all of the measurements from all the machines, the process variables, so the temperatures, the pressures, the flow rates, the tank levels, the parts per minute, and just get those up into a data lake. But the thing that happened is that without context, those data lakes tended to turn into data swamps because it took work all the way around. So here we knew about a machine, we knew about a PLC, it was on a line in a factory, we knew all the parameters. Then we took it all apart, we kind of like atomized it, pushed all of those up into a data lake, and then we turned around and paid consultants or data scientists to try to put it back together again, which is ironic because we already knew what it was originally from the machine. So the very disruptive thing that happened is Amazon realized this, and they created a service called AWS IoT Sitewise. And Sitewise is very unique in that before you start trying to populate the data from a machine, you build a model of that machine first. So now you've got a model of where that machine is, how it works, you've got all of the measurements that are defined. Now you can instantiate that and create many more instances of those and reuse those models, as Pugal was saying. Now, on the left side, we need something in the plant, in the factory, that can connect natively to all that brownfield equipment, that can connect to sensors that we need, like monitoring our electricity coming into the building, monitoring sub-monitoring or sub-metering electric loads on individual machines, so that we can start to get a feel for, okay, we've got all this energy coming into the building, where is it being used? And we wanted to be able to do this with minimal, or in this case, no coding. So we're looking at the Ignition platform on the edge out in the factory. It's connecting to the machines, and using the tools on Ignition, we can create the models of those machines in the factory, and no programming or coding required. Then the connectivity to Amazon, which was already a native capability of Amazon over the last 10 years, is they've got an MQTT broker called AWS IoT Core. So that means that we can make a secure, zero trust, TLS secured connection from the factory into a virtual private cloud owned by the customer. Now, notice that that is an outbound connection, so there's not even any ports open from a cybersecurity standpoint in the plant. And then finally, we take that information that we're publishing in real time, being able to discover those models automatically, build those into Sitewise, and then be able to have access to all of that data in the time series database provided by Sitewise. Now, if you're an Indiana manufacturer and say, well, okay, this is all great, Arlen, but how do you get started with Industry 4.0? Well, with this very unique program that the state has put together in conjunction with Amazon, we can help you get started on your journey with a proven hardware and software solution set that we've already put together. So here I've got my factory over here on the left. I've got my service meter with energy coming in, and where is that energy being consumed? Why, at the end of the month, I got a bill. Well, where did all that energy go? Well, with the MVP product, the Industry 4.0 in a box is that platform containing the Opto22 Epic computer that's running the Ignition platform on it. It also comes with, out of the box, it comes with a sensor that is able to monitor the factory electric service meter at the entrance of your factory. Then it also includes 2 energy monitoring units that can be connected directly to the 3-phase or 2-phase power going into the machines. Then it also provides many of the standard protocols, the Modbuses, the Allen Bradleys, Omron, DMP 3.0, BACnet IP, to be able to connect to those machines. So Industry 4.0 in a box is an industrial application platform with the associated energy sensors that we need to provide zero coding tools to gain insight of the machines associated with energy consumption. But note that it is an ignition platform, so you can grow this to your entire factory and even to multiple locations as required. So like Pugel was saying, is that we're not just throwing a box out in a factory and saying, okay, it's going to connect to the cloud and we're going to do all this. It gives you the start of your Industry 4.0 journey. Now, once we've got those models and all that information in the Ignition platform, we now can create a zero trust TLS secured connection from the factory to Amazon's IoT site-wide service. And then from there, Mega AI will be able to take that and provide us actionable insights into the energy and the manufacturing process that we've got in the plant. So with that, we'll actually go and do a live demonstration here. So I'm going to go back to this topology. And where we're going to start is right here. We're going to start by looking at the Ignition platform and what we've got in there. So what I'm going to do is I'm going to bring up my Industry 4.0 in a box dashboard. And from here, this is the Ignition platform. And from there, and I'll pull this up, is that I've got this notion of a smart factory. And I'm calling that the Amazon Smart Factory. And in that factory, we may have a conveyor, a haul off, a CNC machine. We may have an extruder. Now, before we start going and, again, getting all these individual readings from PLCs and from sensors, the first thing we need to do is, well, let's define a model of what we want to do. And this is called an Ignition User Defined Type, or UDT. And for that, we'll take a look at the first thing we're going to provide in the MVP product is the ability to monitor your electric meter. So we've already predefined the model for a service entry meter that we can read directly the kilowatts and the kilowatt hours from that meter. So that model is already built. We've also got the ability to monitor with an energy monitoring unit from Opto22 3-phase power. So now I've got the ability, and I've already got the model built for all of my energy usage coming in, my totals, both for the energy and for the power. Again, that model is already pre-built. Now, with Ignition, we've also got the ability to do our Modbus protocols or Allen Bradley protocols. So one of the things we're looking at here is we've got this notion of an extruder. And for that extruder, I can create any parameter in that model, the asset ID, the serial number, its location, and all of the measurements and the associated engineering ranges and the engineering units of those measurements that we're going to be publishing to the cloud. Now, once I've defined all that, I can start utilizing that so that I go into my factory and here's my service meter. And we can say, well, that really looks like the power that we're using. And that can go into our extruder machine. And the customer can say, well, yeah, those are the temperatures and the pressures and the loads that I should be seeing. And from that, be able to take an energy monitoring unit and watch the real-time energy usage of that particular machine. Now, we've got all of that in the platform now. And now what we want to do is take all of that insights and all that information and get it into the Amazon Sitewise service. So if we look here, this is my dashboard for my Amazon service, and I'm going into the Sitewise service. You can see here, I've got the ability to create a model, and I've got the ability to create assets, but I don't have any yet. But that is the cool thing here, is that I can connect and automatically create those. So I'm going to go into my Ignition platform. I've got the Cirrus Link modules installed. I'm going to go down to my MQTT connector and see that it's not enabled right now. So I'm going to enable that and save the changes. And at this point in time, I have just created my connection to Amazon, and I'm automatically building those models. So again, from a coding or having to have deep insights into how all of this technology works, pretty much disappears with this approach. So now if I go back to my Sitewise, which remember, 1 minute ago I didn't know anything, and now I've got the model of an extruder, and that model is got all the attributes, the location, the asset ID, the asset serial number, and all of the measurements that I defined in that model. So literally, we are automatically creating the models and the assets from what was in your factory in Indiana. We go back and we refresh here our models. You can see we're creating the bunker. And once all the models are created, then the assets will be created, and all of this information will be flowing real time into the time series database that's in Sitewise. So we've got one more model to create here, and then we'll start creating assets. And boom, all of a sudden, everything that was in my smart factory Ignition instance is now up and modeled in the cloud with all the real-time data flowing into it. So with that, I'm going to go back to the presentation deck here, and we'll go down to Arthy's section, start it up, and Arthy, I'm going to give you keyboard and mouse right now.
Awesome. Thanks, Arlen. Hey, everyone. My name is Arthy. I'm a data scientist at Mega AI. I currently work with several manufacturers across Indiana and help define data science strategy and AI ML execution as part of this rollout. So today I'll be discussing the Mega AI solution within the Energy Insights program. I wanted to briefly flash the Energy Insights architecture here. I think we have already heard a little bit about the architecture of this program from Pugal, each of the different levels and layers involved. I wanted to highlight that Mega AI operates at this top layer, AI and ML powered insights. That basically means that our platform provides end users the capability to visualize operational metrics in near real time on the cloud. So again, we align with that goal of optimizing energy, but we also provide that base for any manufacturing KPI or Industry 4.0 use case for the customer down the line. With that being said, I'll talk through the agenda for today. Really, I'm going to go over some trends in data and the energy industry, and then talk through some more of the specifics around the Mega AI solution and end with a demo. So we've already heard a lot about Industry 4.0 today, or data-driven insights. The Energy Insights solution aims to make these data-driven insights really easily accessible for the end customer and help them streamline their existing operations, again, through the use of data. So basically, we want manufacturers to get to this descriptive analytics all the way through to prescriptive. As an example, we want them to be able to see an energy spike within their data before they see it on their energy bill weeks later. Give them the ability to track that particular spike to a machine failure, for example, or a sensor that's vibrating excessively or overheating. And then even get to the state where they can predict an energy spike will happen in the next couple of weeks and take automated measures to prevent that from happening. It's all about reducing that energy consumption, as Paul mentioned. So this is really where we're seeing the customer move today. An analogy that I like to use is we want to bring this medical model of insights to diagnosis to treatment to the machine floor. So just like a doctor would analyze your body metric data and give you a diagnosis and prescribe you a treatment, we want to do that same thing with machine data and OT data. And we want to do it in a way that's scalable and automated and really brings real value to the customer, in the form of like energy savings or time or money. So beyond data consumption alone, and I wanted to also talk about some trends more specific to the demand side energy industry. Paul has discussed this in a lot of detail, so I'll keep this high level. Essentially, energy expenses are rising due to all the things that we talked about today. Increased regulation, constrained supply, increasing demand, electrification, industrialization, and especially in the state of Indiana, this is a real pressing problem because it's putting a lot of corporate pressure and responsibility for manufacturers to report out energy consumption and steps towards sustainability. We've heard that many large manufacturers today are requiring suppliers to provide metrics on energy consumption and green initiatives. So this is really the current manufacturing climate that we are walking into today. And that's the reason that we have built together, along with the state of Indiana, a minimal viable product to address some of these industry and energy trends and push manufacturers towards data-driven insights and more specifically, energy optimization. So Mega AI aims to help the business user derive those artificial intelligence and machine learning based insights without requiring a data science organization, and as Arlen mentioned, with no code required or no coding capability required. So that means that business users can build and visualize machine and energy insights, monitor their assets, and determine whether a machine is unhealthy or performing normally, really understanding the performance of their machinery and understanding those consumption patterns. And again, in the next couple of weeks, also forecast for energy and other manufacturing capabilities. So now that you know a little bit about what Mega AI provides, I wanted to share a demo of our first product, Mega AI RAIN, or Rapid Actionable Insights Navigator. In the interest of time, I'm not going to go into every possible functionality and what we can do here, but really just walk through the foundational capability of how we generate insights. Oh. Here we go. Yeah, so we can see this is our UI on the left. This is our asset list where we see all of the different machines that are connected to the cloud and publishing data. From there, we can select a particular asset, in this case, the EMU or Energy Monitoring Unit. And then we can select on our asset properties list each of the different measurements that we want to view as an insight or graph. Once we choose the chart type, within a couple of clicks, we can select Create Insights, and that will take us to our dashboard. So these are all of the insights that we just generated. Apparent energy, frequency, apparent power. Yeah, I wanted to highlight here that we're really not in the business of just building out dashboards. Like Pugal mentioned, this is a table stakes requirement from our customers and the state to provide that highly configurable UI to build insights for, representing all of our different machines and assets within AWS Cloud. This is the foundational step to get us into artificial intelligence and machine learning, which is the next Mega AI product that I wanted to talk through today, called Asset Health. But before I even go into that demo, I want to discuss why machine learning and big data is even needed, especially for like small and medium customers that we're currently rolling out this solution with in Indiana. And the reason for that is volume of data. A single machine can generate thousands, if not millions, of data points in, or a few hundred to a few thousands of data points in a single second. If we scale this machine out to 1 to 7 machines, 7 to 10 machines, or even an entire plant floor, we are talking trillions of data points getting published in a single year. That volume of data is way too large for the human mind or even a team or company of people to properly comprehend. We need machine learning toolkits and big data solutions to digest this data in an automated way and explain to us what exactly is going on from the machine health level to the energy consumption level. And that's why we put together our second product, Mega AI's Asset Health. So Asset Health is our unsupervised machine learning solution that monitors assets on a machine floor and tells us and alerts the end user when there's a particular anomaly or abnormality happening within that data. So in this case, we're selecting a couple of assets here to monitor, and we are building out a machine learning model all within a few clicks. Once we generate our model and we build an inference, we're taken to this inference report page. And if we select one of these charts here, we can see at a timestamp to timestamp level, our model will tell us if there has been a particular anomaly detected for any of our assets and what was that reason for the anomaly. What was the exact sensor that triggered the model to say, hey, something is going wrong here. So yeah, that's Asset Health. And what does all of this mean, right? So as demonstrated today and implemented with customers in Indiana, through this program, we have been able to provide a regular business user with the capability to build out complex dashboards and perform anomaly detection fairly simply and with no coding required and no data science org required. So that allows manufacturers to be able to predict energy consumption, detect performance and quality changes, predict for equipment failure, and do that root cause analysis that we just saw. As mentioned, most manufacturers have not even seen their data before. And through this program, we can get them to that level 4 and 5, the AI and ML based insights, and really make Industry 4.0 accessible to the average business end user. So with that, I'd like to thank you all for your time today, and happy 10 years to Cirrus Link.
Thanks, Arthi. That was great. Appreciate it. So we've got a few minutes left here. One of the things I said I would do is that for more information, you can go to energyinsights.tech, get more information on the Indiana State program, how you can join and how you can participate. And with that, Chris, do we have any questions that came up?
Yes, indeed. There have been some great questions. I've been trying to keep on top of a few of them, but here's one I think Pugal should answer. One question on my radar is data ownership and legal accountability with the data regarding where it is stored and who is responsible.
Thanks, Chris. Very good question. It comes up all the time with customers we deal with. Interestingly, more so with the bigger ones than the smaller ones, because smaller ones, customers are more interested in seeing the value immediately. But having said that, that's an important question. To be pretty precise, I think as I mentioned earlier, the data belongs to the customer. Nobody has access to the data other than the customer and the people they want to give access to the data. So that's why the solution, when we built it last year, we started with an approach that we will build this support for virtual private cloud. We will move into a SaaS-based offering, multi-tenants and things like that much later. Because if I look at the broader swath of customers out there, they are not comfortable in going to the public cloud, SaaS-based offerings, at least the bigger name customers. That's why we built this approach. So pretty much if I had to draw an analogy, this is like your bank locker. Whatever valuables you store in the bank locker only is accessible to you as a user who rents that locker. This is no different. This is a virtual private cloud created for a customer with only access for them to store the data and access the data and whoever they want to give permissions to. That is how the data ownership is set up. And security in Amazon is ground zero. It's not level 1 priority or level 2. It is not, that is the ground zero. Anything we do, security is important. So we always respect that. And again, to summarize it, the data ownership belongs to the customer. Nobody can access the data in the current model we have set up unless they want to give access to somebody else.
Okay, excellent. And one thing I just wanted to point out to everybody on the call, we do have a handout that you can download as a PDF, which gives you some kind of bullet points about the topics we've been talking about. One other question, maybe Arlen, it's kind of along the same lines, but a lot of people are asking about the security of the solution, I think from the plant standpoint. So if you could just reiterate about the security on that side.
Sure, thanks, Chris. It's very unique in that if you, I won't go into all of the technical background, but MQTT was very unique in that it leverages TCP/IP. In other words, MQTT doesn't work unless you have a TCP/IP network. And if you look at cybersecurity, one of the largest issues is people being able to come in through an open port, through a firewall, and be able to get access to inside of your infrastructure. Well, with this solution, what we're using is we're using MQTT into Amazon MQTT broker. Again, to Pugal's point, security is ground zero for Amazon. That's why they adopted MQTT almost 10 years ago now. So that means that from the plant, we're making an outbound TCP/IP connection, and there aren't even any ports open at the plant level. So even if a hacker wanted to be looking around for open ports that were in your plant, they're not going to come from this Industry 4.0 in a box solution.
That's great. Another question here about end-to-end testing for functional performance and scaling. I guess people are concerned, how big can this solution go?
I think Pugal and I can both answer that. As seriously, we have Fortune 100 customers that have been using our CirrusLink products. They've been using Amazon services. They've been using SiteWise. So the scale of what we can go to, I think, is multi-plant. It's millions of tags. It's tens, 20, 30,000 tag per second update rates. It can scale very, very well.
Okay. Couple of questions that came in from different people. Is this technology suitable for other types of manufacturers, like a steam boiler manufacturer or sugar manufacturing application? Arlen.
From my standpoint, I mean, again, we do rely on the customer's tribal knowledge. In other words, no matter what industry we would have go into as a team, with Amazon, with the state of Indiana, with CirrusLink, with Opto22, what we do is we try to provide the connectivity to that boiler, to that sugar process, and then the customer helps us understand, okay, well, the parameters that I'm interested for this process are these 5 parameters. Just like I showed you that extruder machine in the demo, that was driven by the customer going, Arlen, for an extruder, these are the process variables that tell us if our process is good and if the output of the extruder is going to be good. So I think that is always going to be a partnership with the customer, the state of Indiana, and the company, the ecosystem that we put together. But we definitely can provide that measurement for those processes, no matter what industry we're going into.
Okay, excellent. All right, then, just to wrap things up, we're at the top of the hour. Pugal, can you just kind of let people know, how do they get started? Who do they call? Where do they go?
I think the best place for that is the slide, what you're showing now in the screen, Chris. As mentioned earlier, the website is energyinsights.tech. It was created earlier this year when the press release came out from State of Indiana and AWS jointly a couple of weeks back. The whole website and FAQs and everything is set up. In fact, this URL has an application form where customers can populate, and then it will reach the right folks in State of Indiana to get the journey started. So the URL present on the screen is the place to go.
Wonderful. Well, thank you all very much for your wonderful presentations today. And thank you very much for everybody for watching in. And we'll sign off there.
Thank you.
Thanks, everyone.